All right, everyone. Welcome to the Lifecycle and Provisioning meeting. I see Boris is joining right now, but I'm going to go ahead and kick it off. We're going to continue the discussion from the API work group, where we were talking about the Kubernetes scenarios. Red Hat was presenting those to us and giving us a view for what they felt were the scenario sets, and then we can deep dive and ask questions into that. So given that, I'm going to turn it over to the Red Hat team so they can continue the discussion we were having in the API meeting last week.
Sounds good. Donald, do you want me to share again? Or
yeah, if you're ready to, that'd be awesome.
Yep. All right, so look good. Last time I had it in presentation mode and was clipping some of it, so I will leave it like this unless. Does it look all right to everyone?
Yeah, it looks good from my side.
Yeah, it looks good.
All right. So yeah, we started. I don't know how many new people are here and how much we should. Sorry, whenever I share screen, I lose my Zoom. I can't see who's there. So we can probably recap maybe real quick on what we talked about at the last OPI API meeting. And then we would try not to dwell too much on what we already talked about, but just go through it really quickly and then continue on. I believe we left off talking about scenario 1, and then we had like 2 through 5 to go through. It's kind of where we left off.
Yep, that's correct.
Okay. All right. So, just to remind everyone, we were kind of in the OPI API meetings, we've been talking about Kubernetes recently, and we kind of felt like in some of the discussion that people were talking across each other. Mainly, they're trying to explain where someone thinks an API lives, but in one particular case, it may live in one place, but in another case, it may live somewhere else. And so I think some of us at Red Hat were talking and kind of wanted to level set and say, here are some of the scenarios that we think that OPI should consider. Now, with the things that we go through, we may not want to tackle them all, or maybe we do, but we can kind of say, yes, I acknowledge that this is a scenario, but we're not going to do it. So that's a perfectly acceptable answer. So we just kind of want to lay these out so that as we're talking about APIs going forward, we should probably say, okay, well, in scenario 1, I think this is what should happen, and so that we're not necessarily talking across each other. For some of the drawings, these are really just a logical model. Like in the picture I have on the screen here, we've got this infrastructure networking pods. So I've got the lines going into it. Like I said in last Thursday's meeting, I tried to draw where I had the pods and it had a little data model beside it, and everything just got super complicated and too busy. So yes, I know the networking is not necessarily going through the pods, and the pods are probably setting up that networking. So this is more of a logical model to kind of help explain how things work. Donald, do you want to add anything to this slide?
No, that's good, thanks.
Okay, so I'll drop down, and then Donald, you kind of went over some of the actors and use cases for the infrastructure.
Yeah, just quickly recapping. So this just helps to highlight where I think the different subsets of the OPI networking API might be consumed and by what type of actor. I won't dwell on that beyond that, really. And the diagram, other than that, just kind of tries to show on the right-hand side a more dynamic use case where we're extending the API when something like a CNF gets deployed onto the DPU that has its own administrative interface. So there's kind of API extensibility as part of the required use cases. That's good.
Yep.
Probably not much more to say on this slide. This slide just covers the pod lifecycle rather than the infrastructure lifecycle. Not much more to say here.
Okay. So we spent a good amount of time talking about scenario 1. This was kind of what we were calling a brownfield, but basically you're taking existing CNIs and wanting to deploy them down on a DPU. So initially, maybe there's not a whole lot that OPI API is being used in this scenario. I think it is a use case. There's a bunch of CNIs out there that there will be changes in order to run on the DPU, but this would be the minimum set in order to do it. I think the main difference here would be the changes that would be required is how you get the like what VF is or which interface is associated with which pod on the host would be the minimal you need to change in the CNI. There may be CNIs like Acilium that's doing a bunch of eBPF work that may be all they want to do. They want to run in this mode so that they can access the Linux eBPF calls directly on the DPU. So yeah, this was just scenario one. I think one of the things we talked about a little bit was that maybe there's not much of an OPI API, but maybe there is something here that, and whether this was an OPI API or lifecycle management, but like what is an interface? A lot of what I've seen are their either VFs or their sub-functions, scalar functions. Is there something that we need to define as OPI to say, this is what is being plugged into the pod? It doesn't have to say it's a VF or a scalar, but how do we model that so that when something new comes down the pipe, that it's generic enough that we can just kind of plug it in? Is it a net dev? What really is it that we're passing around so that when something up on the host is trying to plug this into its pod, what is it? And is that an OPI API or is that a lifecycle management type of definition? So that's kind of where some discussion was last Thursday, if I remember correctly.
Yeah, and the other kind of talking point from Thursday was the idea of a shim CNI or something left on the host side if the majority of the CNI has been moved down to the DPU. Something right. that's actually selecting the VF and plumbing it into the pod on the host side and communicating the CNI requirements down to the DPU if the DPU is not listening directly to the host Kube API server.
Right.
And can you actually add the shim to the picture if you're editing the slides sometime in the future?
Yeah. So
I was just about to say that we did two things. We left some of the Kubernetes components out. And I think that is the next step. Like if maybe either Thursday or the following Thursday, depending on how much time, it would be to go through and maybe add like where, not necessarily for every scenario, but it just generically try to now put Kubernetes on top of that, like where Kubel is, where the Kube API server, because the reason I left it off is you start getting into where you're supporting one cluster or two cluster and where some stuff running. So we're trying to stay a little more generic up front just to get through the scenarios. But I do think that next step is definitely to start adding that on top of it.
And also it was just a little bit of a conscious decision to not issue a revision of these slides before we'd finished presenting them in this form. So although, yeah, so we talked about it on Thursday, but we didn't want to modify the deck until we'd kind of completed it.
And the question in the chat for KOS for the deployment, I think that's true. That's yes.
What was the question?
In the chat, you can see.
Well, I do also have another question, which is it the goal that, we would just view containers as the use case and not really try to get to an abstraction that is below that so that we could use this for all kinds of workloads on the host, not just Kubernetes pods. Even IaaS VMs perhaps could also benefit from, this kind of an architecture. I was wondering if there was a slightly lower level API that the DPU could expose, libvirt perhaps, I don't know, maybe that would.
So 2 points. One, let us go through the slides because I think we do talk about different layers of APIs and that may come out. Point two is, at least in the OPI API meeting, we we're talking about a cloud infrastructure use case, and then we kind of said we want to talk about Kubernetes. And so this was directly a Kubernetes set of scenarios. So yes, it was purposely pod oriented because it is a Kubernetes set of scenarios. So I don't think within OPI we are saying we're only doing Kubernetes. I just think we kind of wanted to take a focus on Kubernetes because we'd ignored it for a long time. So like maybe Boris, correct me if I'm wrong, but that's kind of, this is laid out as purely Kubernetes, but we don't want to say that OPI API is purely Kubernetes. Definitely not.
Yes, we merged the cloud-facing OPI API. The first revision I posted in the chat, so you can look at non-Kubernetes deployments specifically for cloud-based APIs in the chat.
Sounds good. Thank you.
Yeah. Okay, so I think that's kind of recap where we left off, and we're getting ready to move to scenario 2. So is everyone cool with that?
Yeah, go ahead.
Okay. All right, so scenario 2 is, I think, mainly what we've been talking about more in OPI API up to this point. This is where you're basically setting up the full, like a data path through your hardware acceleration block through your vendor SDK. This was kind of the main one I think we've been talking about. You could question whether or not those infrastructure networking nodes reside on the DPU itself or resides up on the host. I believe in the previous diagram, because it was handling all the networking, we kind of assumed it was running on the DPU, but in this case, I think you could either do a stretch model where part of it's running on the DPU or all of it's running in the host and making it pure OPI API calls, or you may have the other way around where it's running fully on the DPU and setting it up that way.
So here, Billy, on the slide, the question is, let's say the hardware acceleration is OVS, right? So the network API is going to be like OVS DB or something like that. But if it's P4, it's completely different model. If it's a VPP or something else, like what I'm asking is, you write here that the network APIs in this case should align closely with Netlink. This is what you're thinking, that for all the hardwares that we see today in different vendors, right? AMD, Intel, Marvell, and NVIDIA, you think that the hardware abstraction and creating these network APIs can be achieved with Netlink style APIs?
I think that's a good question. I think, certainly from my perspective, that's a reasonable working assumption as a starting point. I'd be interested to hear other people's thoughts.
But that's the general idea, just to make sure I understand, right? The general idea is to take all the different implementations from the hardware-specific offload and create some abstraction layer, whether to reuse something that already exists, obviously, and then those infrastructure networking pods or CNIs running inside the DPUs can actually use that API to configure the hardware.
Yeah, so something Netlink-like, I think, is a good, yeah.
I do have a comment on the Netlink part. Netlink is a good high level, as this comment mentions. It's a good high level API. The only drawback I see with Netlink is it's very closely tied to Linux kernel, and most of the data paths are decoupled from Linux kernel. When I say decoupled, they are not part of Linux kernel. So we'll end up offloading things that exist in Linux kernel, which, by the way, has been existing for probably 10, 15, 20 years maybe, because Linux kernel offload for networking is not new, is what I'm trying to say. So instead, if we were to take an approach where we don't have that direct dependency, now in spirit, I agree that Netlink level APIs are good, but if we come to the details, I think it will become somewhat of a question: do we want to really make it that, or do we use something which is giving more freedom than tying ourselves to Linux kernel from the offload point of view? Again, I'm not saying most of the
what options do we have? Like if we're outside of Linux kernel, so what, DPDK, RT flow?
Yeah, I mean, like for example, RTE flow is user plane. It is not tied to let's say the capabilities, and let's say QDisk or queuing and some of those things that Linux kernel offers. That is one option where it is not like glued to it. Certainly, you know, I mean, we do P4, which is completely independent of Linux kernel, but you could also look at OVS, which is arguably tied to Linux kernel, but you can implement that both in user space or Linux kernel, and somewhat, I would say, it's not exactly, but somewhat independent of that. So in other words, most of these choices we talk about could be, but the comment I'm making is coming from the fact that, you know, if you are doing the standard offloads that people have been using for ages, they may not get the value out of DPU, and they will say, well, you know, why do I need ARM cores for this and manage a separate operating system on this device? If I could, like you mentioned, this infrastructure networking could run on the host server itself. And if all you're getting is hardware acceleration, then it's like, do I want to pay for the ARM cores or just roll
But
that?
there are a bunch of other reasons why we may want to disaggregate the host and get the stuff onto the DPU, right? It's not really a choice that is, I mean, we want to make the choice already. We want to move stuff off the host. And we're looking at how the DPU could be a good landing place for that functionality, and how do we abstract away the differences in hardware. So the debate is not whether I want to run it on the host or the DPU. The debate is we've already decided to move it off the host.
Well, I don't know what's the name, KYS.
KY would be good enough. Yeah, KY.
KY, okay. So the reason I'm saying that is because you say that we have already decided. It's the customer.
At least we have.
Huh?
Yeah. At least we have.
We as in, you know, it would be customer, right? Customer would have to see the value.
Right.
If they are not running bare metal workloads, they will really question if I'm paying enough for this device, and is it worth, or should I just pay a couple of x86 cores to do it? Because in general, are they like consuming 30-40% of x86? Probably not. So it will be the customer who will decide that, in my opinion, and they will look at what value they're getting.
Right. Yeah, I agree with you. The customer will decide, obviously. And so both these options should be considered. And so there are cases where we want to run it on the DPU simply because of the predictable performance that we can give the workloads running on the host servers, right? And so whatever API
Sorry, what was it?
It's a separate debate. I think we can have it offline, seriously. But I do think that there is good amount of, you know, cores you could dedicate for these functions, run it in the user land DPDK mode, and still isolate applications from getting affected there. Having said that, yeah, sure. I mean, CPU and CPU isolation is a very well-known techniques. There are a lot of well-known techniques to do that. And same thing with memory and network isolation as well. Especially the cards, a lot of cards today, they give a lot of isolation with respect to what queues are given to which devices, and how to arbitrate the bandwidth and the capacity in the hardware. So there is no unfair advantage to one versus the other. Regardless, I think my main point is that, you know, we should pick a solution which brings out the value of DPUs. Otherwise, we will have a solution, but customers will not buy it because they are not seeing the value of DPUs.
I think, Vipin, your point is clear. And to be back to Billy and Donald, I think that a high-level view of this slide is pretty clear. And I think that the next deep dive that we do is around exactly that. We can list Netlink, we can list RTFlow, we can list all the different options and try to, you know, put pros and cons and choose what is the best one for this type of scenario. Make sense?
So, yeah, and one of the reasons for mentioning Netlink here is that obviously the closer you are, well, if it was Netlink, then when you move infrastructure, CNI infrastructure workloads down to the DPU, then you automatically gain benefit of acceleration without having to rewrite those CNIs. That would be what you would gain from using Netlink.
But only if CNI itself is using Netlink, right? There are CNIs that not using Netlink.
And I have a question on the Netlink approach. Has an analysis been done that Netlink provides everything that we will need going forward? Because, when we
I
had,
think it's exactly the next level deep dive that we're going to have after we finish
Okay.
the slides. Joe.
Agreed.
And I would agree. And I think when you say, does it provide, I think it depends on the CNI, because I think it might have been Boris that said that not all CNIs, will use NetLink, some use OVS, some use, every CNI is slightly different. So
right.
that's kind of where everything gets muddied here, because there
So
is
probably, Billy, whatever we
one
choose
thing
is
that
going to
fits.
be a bad choice, right?
Well,
Right.
we know-
Yeah.
well,
Exactly.
That might also be the case, but we know from doing work in other network operating systems and trying to map into NetLink, in particular, Dell OS 10. And when we had it open, it was open switch. We can talk about this. Everything was mapped into NetLink, but there were things missing so we didn't represent them as part of the kernel state. And there were gymnastics you had to do if you were going to be a full L3 switch / router, which the DPU has pretensions for. Now, with CNI, we may not need all that, which is why I'm asking the question the way I did, which is, do we have an analysis that says NetLink maps to CNI and the future of CNI perfectly, therefore it's great for the CNI piece. It may not be great for the general networking or sufficient for the general networking, but it is great for CNI. Has that analysis been done?
No,
I
I
don't
would
believe
say
it
I would
has.
say no, Joe. That has not been.
So do we
But I-
need to do that analysis to agree on, say, NetLink for this? Again, I like the idea in general, but do we need that analysis and go, well, here's how it maps and it's good enough, and in the future we may have to extend, and we have to actually extend NetLink as well? Again, we probably need some kind of plan or thinking along those lines.
Do we need a concept of like a canonical CNI interface so that we can abstract and then map to the individual CNIs? Because you're never going to solve everything for every CNI in one place, right?
Well, I don't know, what does the Kubernetes CNI world say about that? What's the state of the union from the CNI Kubernetes world?
Each and everyone is doing what they want.
Everybody just does what they want.
Everyone just does what they want. Yes.
So
Some use OVS, some use Linux kernel and eBPF, some use
And the
Routing.
customer, right, Billy? The
Yeah.
customer basically chooses what he wants to deploy, and this is what's directing what CNI he is going to deploy and use.
right. And some of it is that, and some of it is, the customer could care less what's under the hood. It's the higher level features that a particular CNI offers, would be my guess. It's like, they don't care if you're using OVS or you're using eBPF, as long as, you've got the load balancer, you've got the, network policy that they need, or you have the observability that they need. I think it's more the things that they see, less the underlying technology. That would be my guess, but I'd love to hear others. But
So I propose to move to the next slide, and I agree that the next deep dive is going to be here on NetLink itself and alternatives. People who have familiarity, like VPN, you have RT flow suggestion and stuff like that. Maybe we can come up in the Thursday and discuss specifically deep dive on this and see if we can commonize on this hardware abstraction interface. If we cannot, then I would really like to understand how can we push to CNIs different types of implementations, or how can we accommodate or stay with their native interfaces, and what OPI will become in this space.
yeah, that sounds good to me. Joe, you said that you've had experience with the mapping of the NetLink to OVS. Is that what you were saying?
Then we mapped to our own OS that had aspects in common with Sonic. So
Okay.
for Dell OS 10, basically maps to NetLink in a Debian Linux instance. We use Debian Linux instance, and then we communicated with the kernel, and we had tap interfaces that sucked out the packets. We basically made the interfaces tap interfaces, and then we hid the fact that we offloaded them. We made it look to the kernel like it was still their interfaces, and we had a stream of NetLink events going back and forth between our software and the kernel to make sure that the kernel state matched the part of the OS 10 state that was represented by the kernel state. So we kept them in sync, which is a trick in and of itself to keep those states in sync. And I didn't implement that, but again, we have if we wanted to need to go deeper, we can get a couple of people who did implement that in a smaller call and do some work there.
Okay.
If we need to. But again, Netlink in and of itself is great. I mean, we used it. The question is, does it have the coverage? Does it have all of the operations that we need to support the CNIs? And the answer might be yes. I was asking, do we know that answer? But I think we need to know that answer. Does that make sense, Donald?
I have a proposal for how we can position the Netlink and OPI APIs described in my slide deck. So if we have time to walk through in the next meeting or so, I think that will help.
Yeah, excellent, Toshi. We have you on the next after we finish with this deck. We're going through your deck either today or the Thursday, depending on the time availability. Thanks.
Yep. Sounds good. All right. So I'll move on to the next one. I think you have the gist of it. We can decide what that box looks like in the next. And I think that was kind of the purpose, just to say that's what's there's something there, and we need to decide on what it is. All right. So for the third scenario, so this one is looking at more of a workload, wanting to access some type of acceleration directly. So whether it's encryption, they have their own tunnel they want to encrypt, whether it's compression, it's some other type of acceleration that we haven't thought of yet. There may be another set of APIs that they need to call in order to have access to some type of acceleration that they may want.
A Billy question on this one. So this is somewhat independent of Kubernetes, isn't it? Because this is look-aside acceleration APIs that you're referring to. So I'm not saying it's not relevant to pods, but is it directly related to Kubernetes part? If not, maybe we can deprioritize this against other scenarios.
Yeah. So like I said at the beginning, I think that we could get into this and decide that, what, scenario 3 is something we don't want to support, which is fine. But I think there has been talk of, being able to, you're right, it is not necessarily always just a Kubernetes, but there may be a workload in a pod that needs particular acceleration. So
definitely.
So,
I'm not saying use case is not valid. All I was saying is all I was asking was if this is related to Kubernetes. That's all. Yeah.
I mean, I think it is, but if we decide we want to deprioritize it, that is fine too. I just think we need to acknowledge that, when we're talking that, there may be people asking for one of these low level ones, and we can just say, yeah, we've talked about it and we decided that's something we're not going to do right now, or we're not going to do at all. So just as long as,
So the question here is, you're thinking about like virtual function interface here from the hardware acceleration tool inside the pods, or something else? We can definitely describe it if it's over PCI Express, right? We can definitely define different types of functions, not just networking functions or storage functions. We can do everything over virtual and physical functions, expose them to inside the pod, and then you can do whatever you want on top of that. No? So
I will repeat what your original, am I assuming it's a VF? Is that what you said?
Yeah.
Or
Well, it makes sense to assume that this is, or standardized on virtual and physical function interface.
I don't know. I mean, is there something like this you can do with a sub function? And is that considered, I mean, that's not necessarily a VF. So are you saying that something like sub functions would never work for this, or, I guess would be my question. And then I don't think that we also didn't specify whether this was the primary or secondary interface being plumbed into the pod. So we kind of left it vague on purpose.
So sub function for me, virtual function, sub functions in the same category. So without making an extension, it's kind of the same. Then
yes, I kind of assumed that, but I kind of assumed that's what all these interfaces were. which is.
Am I being overgeneralistic if I say that virtual functions are typically net devs? Or you can use virtual functions for any
You
type
can use for anything. They can have networking, storage, compression. You can have a lot of those different.
Okay.
Does this box also include GPUs as well, or is this just compression and some other fixed function activities? This blue box that you have here.
Excellent question.
Yeah.
Yeah, it's a good question.
You know, I mean, most of what OPI API, what we're talking networking for the most part. I mean, the OPI API is handling storage and other things as well, but a lot of this current conversation is around the networking part. I think we were just trying to say there may be some type of acceleration that the pod needs. We were thinking it from networking, but there may be others as well. I think the point though was that you know, this could be a lower level set of APIs. I think part of what we're trying to get across on all these slides is that we may either have a hierarchy or multi-layer of APIs, a higher level for the scenario 2 where we're setting up the whole data plane to run in the acceleration, but this may be we want to expose some low level one just for pod interaction if necessary. And like I said, we may want to say, yes, this is a scenario, but we're not going to support it. That's a valid answer too. I just think we need to acknowledge that there may be people asking for things like this.
And let's deep dive on the two opens that you have. Like you're thinking about two sets of APIs. One is data processing, which we talked about virtual functions or scalable functions, whatever we have, and one control. Actually, you know, have 3 functions on these BDFs, right? This is more a control. Expose me 3 engines, something like that. This is the control that you're talking about, or QDEPs, like let's say stuff like that.
Yeah, that's exactly right, Boris.
Okay.
And
this is a color coding, right, as well, the blue and the magenta, whatever.
Yeah.
Would you consider as part of the OPI spec APIs that would flash a new firmware to this device, the DPU device as well? You know, and perhaps maybe, you know, you should classify these APIs as management APIs that will allow you to partition the device into multiple VFs. And maybe there are some other APIs that would multiplex. If it's a software, you know, if it's to be multiplexed in software, we could do that as well. And then maybe there should be some APIs for firmware updates and things like that.
Yeah, so the firmware updates, the reboot of the device, the synchronization between the host, all of that is being in the Lifecycle group. So outside of this presentation, but we are doing that on this call.
Okay, sounds good. Thanks.
But there will be APIs associated with that we'll have to flesh out. So yes, that answers your question, I think.
Thank you.
All right, so now the next scenario was really just saying that it's really just combination 2 and 3. So it's just saying that you may want both. And so we didn't want to just say if we were doing some of the lower level acceleration, it doesn't preclude the other one. So this one, there's not a whole lot, there's nothing added here other than we just combined 2 and 3. So I don't think there's any other points on this one that we haven't talked about.
Yeah, agree, Billy.
And then the last one is it's come up a couple of times. So we just kind of wanted to point out that I think there is a need for being able to run workloads on the DPU, maybe outside of the pure like CNI itself, some type of infra pod, whether it's a firewall, load balancing, you know, some type of sub function chaining, just workloads that are down on that can be scheduled on the DPU. And then the question is, you know, how do those get plumbed into your hardware acceleration? Because they're kind of outside of some of the CNI work potentially. But just kind of wanted to point out that we think that being able to run workloads down there independent of more of your CNI are important.
Why do you say they're outside of the CNI? InfraPod 8 has its own CNI, correct?
when we say outside the CNI, because it's not a bundled component of the CNI. Say, for example, this is a load balancer or a firewall, which is provided by a third-party vendor. And so it's going into a service function chain, but its network configuration needs orchestrated by the CNI, but it's providing some kind of inline extension.
Yeah, but it might be its own whole cluster, right? I mean, nothing to do with the host cluster.
Could be, yes.
It could be both. That's a good question. It could be
this,
outside.
This to me is the most interesting DPU use case we've looked at. Everything else smells like accelerated SmartNIC to me. This looks like a real DPU use case.
If we were to move the host network port 7 into the DPU itself, is that what the port 8 is really?
No.
So there is going
Think
to be
about port 8 as firewall, for example.
Firewall or load balancer.
So it exists outside of the applications running on the host.
Right. So the management is still from the host side, which is port 7.
No, the host is not. The management is not from the host. It's probably external on the network.
Yeah, it's the infra admin.
It's infrastructure. The host is running applications. The DPU is running infrastructure. They are not necessarily the same management or control plane.
In this scenario, do we assume that the blue box below, which is running on the DPU, is also running a Kubernetes node, which is controlled by a separate Kubernetes master?
That is one use case, yes, for sure.
And as KY is saying, it could be managed from the host if the customer chooses to manage it from the host. It could be like Tim saying, managed completely independently from the independent cluster.
For me, the most interesting case is if I ran the Kubernetes master on the DPU, and all the worker nodes could be on the host.
That's another topology.
Yeah, there's multiple topologies, and we purposely left out topologies on this, but they need to be discussed. But we kind of want to get through some of the scenarios first. I mean, you could have like one cluster where, each, like the DPU is a node and the host is a node. You could do it the other way, like we just said, that where it's your master's down on the DPU. I mean, there's multiple ways to run it. So we're kind of wanting to get away from that, at least at this drawings, and just kind of say, hey, we want to be able to run some type of workload down on the DPU. And then, there's two types of down there. Is it servicing the set of pods on the host? Is it purely a load balancer, so it needs to be service aware for pods running on the host, or is it something that's pure infrastructure outside of it and it's just doing some other type of firewalling or something where it doesn't need to? I think both scenarios are possible.
Yeah, the most generic way of thinking about it is that the host server is a node and the DPU is a node, and in the Kubernetes networks, and they may or may not be in the same cluster with the same master. But the location of the master isn't really the most interesting thing here.
Right.
And thinking of the masters as being remote is the easiest way to just take that out of the equation for now.
Right. And the benefit is that you're decoupling the applications layer from the infrastructure completely in this case, thereby not even overlapping not just the infrastructure pods or daemon sets, but also the control plane that manages those.
But the function chaining, for me, it's still unclear, right? It's probably going to be very difficult. Like, okay, you plugged in your new application, your new pod, but then how you do the function chaining between the networking and this pod. I think this also relates to the opens that you mentioned here, Billy and Donald.
Yeah, lots of opens. Don't get us wrong. We're a lot to try to figure out here.
Yeah, we're in the introductory chapter of the book here, right? So
right.
Yep. Yeah, not to complicate the picture, is it within scope to talk about multiple DPU cards that might be plugging into a host, each of the DPU cards having different sets of acceleration units? One doing networking, one doing storage, one doing maybe GPU and so on. Is that in scope or out of scope of this discussion?
It's probably another use case that's within the discussion, but I think it's covered by the use cases that are here. It's just how you're looking at it from the particular DPU elements. So you can still have multiple.
Yeah, I'm still looking at the point of view of would I have a single management unit that drives all these DPUs outside of the host, and would be kind of standardized on APIs for the lifecycle part of it, as well as provisioning part from this one of the DPUs doubling as both a DPU plus the management engine that would orchestrate across DPUs.
So I think if you look at the color coding here, KY, so the use case that you're talking about is the purple one, the admin OPI API. This is how you talk to your external entity and orchestration from outside. The green one is already you are inside DPU, you're running your workload inside, whether it's networking or firewall function or whatever you have, how you interact with the hardware acceleration, because we have so much variety of different hardware acceleration across vendors. So this is why I think those color coding trying to help us to see that there are a lot of different APIs on different layers that we can actually define. And whether we take upon all of those approaches or just pick ones, the most important ones, and start with them, I think this is for this group exactly to decide together. Yeah.
Right. And so as we're talking going forward, we kind of need to say, these are the APIs I'm talking about. So we're talking apples to apples when we're discussing some of it.
So what do we mean by the admin OPI bubble that straddles the green and the blue boxes on the left side?
Really just that there is an admin API onto the DPU to be able to provision infrastructure networking pods or processes. And
give an example, Donald, like what?
Yeah, and a lot of that is likely to be kind of lifecycle management, I guess.
Yeah, what color are we calling that?
Magenta.
So would it be unreasonable to think that there's a magenta bubble on the left edge of the infrastructure networking box? Or is that sort of what you're implying by putting it on the blue edge? That you can reach into that infrastructure networking from outside and configure it?
Well, so I think the point was really to show that we need to be able to actually deploy infrastructure networking. And that's why it's on the blue box rather than on the infrastructure networking box. And if you were wanting, and this is carried forward from the first scenario, where if you were trying to deploy CNI functionality unchanged, then there would be no OPI API on any of the pods in that box. You'd be managing it just by purely deploying them. And it's a very gray area. So we need to break into that, and that's probably another area for deep dive discussion on.
But just to give you examples, Donald, for example, deploying the CNI inside the DPU, one scenario, restart the pod, for example, for networking infrastructure, another one, right? Those are just a few examples of what you mean by admin OPIs.
That's right, yeah. And the reason that there's a magenta blob on the infra pod is because that was the scenario where we've got a third-party, say, firewall or load balancer, and it presents a new admin interface or an extension to the admin OPI API so that you can configure its functionality, such as the load balancing behavior and so on.
Okay, I understand a little better, I think. Thank you.
So those are the 5 scenarios. I'm trying to remember what we had next here.
We're just starting to briefly introduce the work that we're looking at to evaluate open config in the context of administrating network functions running on the DPU.
Right. So these are still the work in progress. We're trying to work through some how we want to think through some of that.
Right. And so this is a kind of brief summary of it. And the next slide was what Christoph presented 2 weeks ago. Is that correct?
Yes, I think it was 2 weeks ago.
We can spend some time on this slide if people are interested and walk through this again, just to remind what was discussed 2 weeks ago.
Yeah, so I mean, in this, really what we're showing is that from a telco perspective, especially, I would say that using something like OpenConfig over NetConf fits with some of their automation tooling and aligns well with what they're already doing for things like top of rack switches and things like that. So they can kind of use consistent tooling for managing resources on the DPUs as well as, you know, their other networking infra. The right-hand half of the diagram drills into a little bit more detail of showing, well, if we were to deploy a third-party CNF, then we'd want to be able to extend the OpenCon or the API, the OPI APIs, and if that was a netconf yang extension module, then it would automatically extend the netconf APIs that are exposed off the DPU. That's kind of the broad summary of what the diagram's showing.
So to color code, the RESTconf proposal here is RESTconf and NetConf proposal here is the OPI API proposal.
It's the magenta admin OPI API.
Mm. So again,
in fact, this diagram is all really about considering lifecycle of the magenta admin API rather than service API or low-level network API.
No, to the accelerator XYZ, this is a more networking API, but it's just showing the VFs.
Yeah,
and message. Yeah,
that's a fair point. Yeah,
it's the initial configuration API is what you're referring to. So
yeah,
what you set up initially, and then you're going to deploy each time when it powers up. Yep. Okay.
And we're experimenting at the moment just with doing exactly this with Netopeer and Yang sysrepo with the OpenConfig Yang models, unchanged rather than generating gRPC off them and building gRPC-based backends. It gives us a little bit more kind of dynamicity and flexibility, and we'll hopefully, well, we're working towards being able to demonstrate a POC of that in the near future.
Yeah, and then we can look into, once we have something generated, we can look into aligning that with VPN proposal and the cloud-based APIs if we can come up with something.
Yes, exactly.
Unified. So again, Donald, if you're editing the slides after we finish the presentation, I think that just adding a little bit of the same color coding on this slide will help to identify the admin versus the network functions API.
Yeah, thanks, Boris. That's a good suggestion. And I think we'll also probably work towards at least having a draft set of slides that we can discuss, which are introducing some of the Kubernetes function placement in the overlaying onto these diagrams. So when we're talking about where the kubelet runs, where kubeAPI servers run, and so on and so forth.
Oh, that'd be good.
Cool, awesome, good discussion.
Okay.
Yeah, very good. Distilling of thoughts here. What are the next steps? Like, do we focus on one of the scenarios to double down? Do we pick brownfield versus greenfield type of alternative? Because the amount of work is going to be quite a bit, no matter what direction we take. I'm not saying we need to do it now, but at least start to narrow it down. I don't know what you guys think.
I think as we deep dive, we probably have to start looking at focusing on one of the scenarios and then trying to drive it all the way to fruition.
For me, we identify kind of two major points. One is admin APIs, and I think that NetConf, RESTconf may be one proposal, so we can take this direction and try to work through it. Look at what other proposals we have in that space and what can be our admin APIs. And the second one is network APIs, the green boxes, is how we abstract the hardware. And I think that either RTFlow or Netlink or any other proposals can be utilized in that space So we can, again, list the different options, try to see pros and cons, and try to choose the best one for us. I think if I'm missing something, let me know, but I think those are the two major focus points that we need to have going forward and deep dive into each and every one.
So one comment I want to make here is, as we look at the standardizing on the infrastructure APIs, OPI APIs, we should look at defining them at the lowest possible level. That would allow us to address what we discussed today, which is Kubernetes pods, which obviously is a very important use case for all of us, but also non-Kubernetes standard, IaaS, VM use case as well, where we might just want to be able to provision the NIC, get a VF out, and somehow just pass it through to the guest with nothing, no code running in the host, for instance, to pass it through. So that would be the use case that I would be interested in.
Devi, question: Do you see those workloads being also managed by Kubernetes, or irrespective of that? Because Kubernetes definitely.
Obviously, Kubernetes is a big thing for us, and that's an important use case. But that's not the only use case. And so, if we build something at a slightly lower level, we could layer Kubernetes support on top of that, and also use it in non-Kubernetes environments too. But certainly Kubernetes is an extraordinarily important use case.
Right. No, what I was alluding to was Kubernetes also aims to, or rather, there is some school of thought of managing VMs and everything through Kubernetes as well. So I was just curious if you are pointing in that direction, or is it
that's an interesting direction, obviously, yeah, but that's a little bit down the road, I think.
Okay.
All right, we got about 4 minutes left. I don't think that's enough time, Tashi, for you to cover what you had. So the next meeting on Thursday, we'll make sure that Tashi can present what he has put
this
together.
week.
I'm sorry, this week.
Not next week. This week.
I'm used to the API meetings being, and then the next week. Sorry, Boris. Yes, this week.
This
Thursday.
week.
Boris, 2024. We're not touching that till 2024.
No.
Sorry, bad humor.
You got a free meeting, Mark. Today was a free meeting for you.
Yeah, today was an extra.
You assume it's free. We and Mark have a deal.
Little payback, huh?
That's right. He's going to take over some of mine.
Okay, good meeting today. Thank you.
All right, thank you, everyone. That was very good.
Thank you all.
That's
thank
great.
you for,
Thanks, everyone.
thanks for the time.